Yeah, so I started recording. Okay, yeah. Hi everyone. Let me introduce myself. Like, okay, let me introduce myself. Like, I am Srinivas, working as a senior design engineer in AMD. Okay, and this verification expert is my personal space. Like, I am doing it out of hobby to teach something to people which I learned myself. Okay, yeah. So let's get started with the actual presentation. Okay, so yeah, this webinar is like a very basic thing, like what I did a couple of months. I'm working with this GitHub Copilot. So I found it's not that much, but unlike other people are doing with this thing, right? Software people are using this for their coding because uh, essentially GitHub Copilot works well with software. Okay, like Python and other things. Okay, I give it a try to work on with Verilog and SystemVerilog. Okay, it's pretty much okay, but we cannot do much there. Okay, but here what I want to show you is like I use Cocotb, which is a Python based test bench framework. Okay, for RTL verification. Since Copilot can do very well with Python, so I want to show something which is useful for RTL verification also. Okay, so in this demo, maybe mostly I focus on. That's why I took a very simple design. Okay, which Copilot can create, but my main focus is on verification side. Okay, so that like verification is a local one, right? You don't have any issues with that. Okay, okay, then yeah. Just give me a second. Okay, so this I am doing out of my own interest, so nothing from my company. So this is just a disclaimer, so that like I can avoid anything in future. Okay. So here is the agenda. Okay. I want to introduce what is GitHub Copilot and other things, and just how we can use this. RTL design and verification side, and then like we'll focus on RTL design, then test bench with the Cocotb. Then we'll see what are the gains we'll get from this thing. Okay. Then coming to like what is the code quality and reliability, like how far we can use this thing for our actual projects. Okay, then I will discuss about the future things and challenges, and lastly, like most of the time we spend on demo. Okay, which is like we start from the scratch and do a simple design and a verification with that. Okay, so at the end, maybe I'll open for questions via chat, or maybe I will unmute you. Okay, so let's get started. Uh, we have prerequisites for this thing. Like since I'm not explaining all in detail, like I expect you have a good understanding of Verilog or SystemVerilog and other things. Okay. Uh, in this webinar, we are not going to discuss how to install Copilot, how to register, all those things. I have in my workspace, I can just show you what I have. Okay. And digital design basics also and other things also we are not going to discuss. And Cocotb, I will explain, but I will keep it very minimal. Okay. Maybe that's a topic for another meeting. Okay. So let me introduce, tell like what is GitHub Copilot. So it's a code assistant, AI-powered code assistant. Okay, it's developed by OpenAI along with Microsoft. Okay, so this was owned by Microsoft only. Okay, so along with other, I mean, few more code editors, they integrated with the VS Code, which I am going to use in this demo. Okay, so that like it, we can see how it helps in real time, and how it helps to write a test bench and other things. Okay, so here are the features of the Copilot. Like it helps you to do some auto completion. The moment you write something, like it guess what you are going to write and give a completion. Okay, and code suggestion. Auto completion is something like only few tokens, like a few words. What are the next things you are going to write? But code suggestion is more than that. Okay, you have to explain what you required in a plain text, and it can generate entire blocks of code for you. Okay, and it's like a natural language prompting. Like you can use simple English to tell the Copilot what you want. Okay, and it will provide the code, and it's up to you. Like after reviewing, you tweak it or ask for another suggestion or modification. Okay, so and it has a awareness of in what context you are talking. Like say you highlight some code and ask a question, it can tell you about it, or refactor for you, or if you have two files open side by side, it can understand both files content, and can give more suggestions based on that context. Okay, so why we required? Okay, so it enhances your productivity. Okay, because most of the time, like we try to, like, we have a high level understanding what we are going to write and other things, but most of the time, like, we end up writing code line after line, right? So it will help the routine tasks. You can ask it, like when you're stuck, or if you don't know the syntax and other things. Okay, it will reduce your cognitive load, like mental things. You can focus on high level logic and architecture, and other things are handled by the text editor itself. Okay, and not only that, like if you are learning the language, if you are at the starting stage, right, normally we go to other documentation, or Google it, or language reference manuals, some textbooks we go, right? So it will reduce all those things, right? You can directly ask the questions here, or you may see something different which you may not seen earlier. Okay, that Copilot suggests some thing. Okay, yeah, but it comes with some framework and copyright issues, because this Copilot is trained on globally available public code bases from the GitHub and other things, right? So most of the time it ends up giving for a small code snippets. Most of the time it end up giving the same code as it is. Okay, say if I ask for a flip flop, obviously it cannot invent anything new, right? So whatever there, like a lot of people may have those things, so it's simply copy and paste here. Okay, which comes as a like a copyright issue. Okay, so like if you create a large code base on this thing, okay, and there are concerns like who owns this code, is it legally compliance or not, and all those things with it. So while you are using, we have to consider all those things. Like you should have a appropriate license headers in your source code if it is used by others, if you release it as open source, like that. Okay, okay, so it's like you have to use the licenses. Like copyleft licenses are like if a source code has a license header on it, with you have to just forward it as it is sometimes. Okay, if you use this as it is. Okay, so this advice, like legally we don't want to have any complications, right? So if it is for a production environment, we always have to consult the legal, so that like we avoid future issues. Okay, then coming to the actual topic, like we want to use this for RTL design and verification as well, like to some extent. Okay. So it will accelerate your development. Like you can quickly come up with the ideas and implement them, like at least twice to 10x in some cases. Okay. So let us go to the how it helps in the RTL design. Okay. So you don't need to remember the syntax. Okay. Like most of the time, it will give the correct syntax depending on the context. And yeah, so other you can ask the code segments with the appropriate comments and all those things. You can ask it to refactor your code for more readability and other things. Okay, so it will accelerate your design process, so that like with a minimal effort you can quickly come up with the complex codes if you are aware what exactly you want. Okay, sometimes you can ask for suggestions, like if you don't know how to proceed, maybe you can have open the chat in the Copilot chat and have a like open-ended questions also. Okay, so since most of the stuff it can do on its own with minimal context, so people can work on the high level architectural things, okay, rather than routine coding things. Okay, so yeah, Copilot influence, like as it works with most of the programming languages, it works with Verilog or SystemVerilog also. So I mean, you don't need to do anything extra unless like it was updated by training. Okay. Yeah, but you will see the quality and code consistency, because it as we write, right, based on your inputs, it adapt to a style, okay, which suits for you. Okay, like after some projects, maybe it will write exactly how you write before. Okay, because it will adapt to your style of coding. Okay, so it may, when you ask, right, it may show some patterns which you may not seen before. That's way you can learn uh, more things, right? You can understand, you can see what are the new things people are doing, and what are the best practices and other implementations which may you may not heard before. Okay, so that's how it will work. You can collaborate with the teams and do like remote sessions within the VS Code, so that like more people, like this is like your pair programming. Like one is doing all those things, other one is overview, right? You can extend to other people also. Like yeah. So coming to the test benches, like since I mean, we are using Cocotb, which is a Python-based framework for writing test benches, and since it is good at, I mean, lot of Python code exists, right? So most of the time, like it will give a like accurate code suggestions. Okay, and it has a context on one side. I mean, all you have to do is like it is a limited context, right? So you cannot understand the entire project. Okay, all you have to do is like open the RTL file one place, and your test bench on another window. Then now it has visibility of both. Okay, beyond two or three files, I don't know, it can do, but at least two active, up to two active windows, Copilot can understand your context. On one side, if you have a RTL design, if you ask other side like Python side, if you ask about any question or any things, it knows what are the variables and other things. At least like maybe it has to improve, but at least it can do that. Okay, so as with RTL design, now it can accelerate your test benches also. But with a test driven development, you can quickly add your test cases with this thing and test your existing RTL. Okay, and quickly you can find the bugs and iterate fast. Okay, so this also integrates well with the workflow. Okay, Python task, classes, and other things, you can give a reasonably good quality, and it has a consistency. Okay. Yeah. So as I told earlier, you can give a advantage of like in terms of your productivity and the timelines. Okay, and you can collaborate with other people within the framework, and you can share and reuse and other things. Okay. Yeah. So it helps you to reduce the manual coding efforts. Okay. So only we have to think at the logic level, like based on these suggestions, and you can improve your productivity. Okay. Coming to the code quality, as I told, most of the stuff is open source trained. Okay. Initially, you may not expect good things, but they may be working. So it's important to review the code and testing and validate ourselves. Okay. We have to ensure like whether that was like every team will have their own every team will have their own style guide and other things, right? We have to ensure whether they are followed or not. But once like you keep on adding, right, it can adapt to your style, and it can understand. Okay. And yeah, so still it is like for RTL design, it is still uh, the basic level, like unlike the software part. But for verification in Python, maybe it can do a good thing. Okay, so it may have like limitations, but after few projects, it quickly learns your style of coding, and it can give uh, um, the way you write yourself. Okay, so it reduces the time you spend on the coding, but at the end of the day, it can give what exactly you write. Okay. So maybe I start demo, like whatever I told so far. Maybe it's just a simple introduction. Maybe I can go directly to the. Yeah. So far, like if you have any things to ask before demo, maybe I can quickly explain and start the demo. Yeah. Please use the chat if you have any questions, or just put a message there, or I can unmute you. Yeah, if you don't have any questions, maybe I can directly go to the demo. Yeah, shall I go?
Yes, let's start with demo.
Okay, we have a question, right? What are the other verification and design tools in industry? Okay, so in industry, like verification, most of the like heavy lifting is done by UVM test benches. Okay, like to sign off that everything is working, like people use UVM, I mean SystemVerilog based UVM only. Okay, and other design tools like we have Questa, VCS, and other things for your RTL design part. Okay. Any more questions? Yeah. Okay. Maybe I'll start with demo. Okay. So let me open the terminal. Okay. Just tell me like whether you are able to see the screen. I mean, I open the VS Code, so are you able to see the screen, and like font is visible or not? Is the font visible? I mean, is it good, or should I increase more?
It's visible, but I think there's a pop-up screen like the previous slide.
Yeah, pardon. I think I lost your audio. Maybe can you put it in the chat? Maybe. Okay, so maybe I will take more questions at the end of the webinar. I will start with the demo. Okay, so yeah, so I just starting with the empty folder. I have only presentation here. Okay, so what I can do is I mean, instead of creating all the things from the scratch, I just prepared a template for my uh, design project. So I can just create a template from here. Okay. Yeah, this template is available at my repo, like VerificationXpert / Cocotb verification templates. So I just using cookiecutter, which is a Python-based project, I mean template. So I'm just creating directly from that template. Okay. Okay. So let us name our project name as Simple ALU. Okay. And yeah, I will leave the author. Our DUT, like we want to run verification on our ALU module. So I'm giving that module name as ALU. Then clock name, like I'm keeping as a CLK. And reset also I'm keeping as is. So the polarity also I'm keeping it as a negative polarity for reset. Then yeah, here I'm going to use the Verilator as my simulator, RTL simulator. Okay. Yeah, that's it. So now we have a simple ALU folder here. Maybe I will go it. Okay. So here we have, maybe I'll stop presentation. Just let us go to the. Okay. So in this folder, we have ALU.sv. Like this is a simple code, just a template to start with, and other place like we have a Python test bench. Like maybe I can explain a later thing how this Cocotb test bench works. But as of now, I can show you right, this 28th line to here is actual like to set the variables and what are your source files and other things, and what are your test cases and other things. Okay. So once we set all those things right, this build stage is like a compiler. Okay. Like we have to give all your sources and you have to tell what is your DUT. Okay. And it will compile. And last one is the actual simulation to run. Okay. Like this is just you can reuse the same thing. Okay. There is nothing to add anything there, but actually we have to add our test benches, right? Test cases. Here I just by default I added one hello test case. Okay, so that like once we create the template, we come to know whether it is working or not, right? So I can directly go there and so by the way, I'm using PyTest to run my Python, I mean, Cocotb test case. Just as a sanity, I'm just running the PyTest after creating the template. So in the background, it will run. Like if you want, you can add a verbose thing to PyTest. It can show what is going behind. But as of now, just I'm keeping simple. Yeah. Okay. So it took some time to compile and run. So, but yeah, it was good to go. Okay. So maybe before going, like I can just explain what we did so far. Okay. I explained how to compile, add the sources and compile and test, right? Then actual test is here. Like anything test, you have to define as a coroutine or like a synchronous def. And on top of it, you have to use cocotb.test decorator. Okay. Then DUT is the one which passes as argument to this test. Okay, that all those things are covered in the Cocotb framework, so you don't need to worry about it. Okay, so then here actual test, like I am just generating a clock. Okay, and putting it on a DUT.clock, so which is the input to your module, and similarly reset n. Okay, that this reset DUT, this is the defined one above. I mean, this is the here. Okay, here I am just initially I am keeping the device in the reset. After some 10 clock cycles, I am releasing the reset, so that like at the end of 10 cycles, okay, your DUT is coming out of reset. Okay, then after that, like just I'm waiting. I'm just waiting for the reset. Okay, then I just kept one equal to one. Okay, just to see if it is passing or not. Okay, but this is like nothing to do with our actual test. I can just remove it. Okay. Okay. Now coming to the actual design, let us have a, I mean, design first. Okay. Okay. So actually, like my Copilot was, I mean, already enabled. Okay. If you see, right, the moment I write the code, it is trying to help me. Okay, so that gray color code was actually came from the Cocotb. I mean, sorry, Copilot as this. So it looks good for me. So I'm just accepting by enter tab. Okay, and but I want to add more things, right? So this as a following page. So yeah, you can see, right, as I am entering, right, it is giving me suggestions and I am accepting them. Okay, without even without telling anything to it, it is trying to understand from the context. Okay, because we opened a file name with alu.sv, so it can understand it's a SystemVerilog file, and we are about to write some arithmetic logic unit. Okay, so without telling any extra word, it try to understand that. Okay, from the signals it is trying to guess like it's active low reset input. Okay, so yeah, we can take as is, and maybe we can just okay, maybe just I'll make it 32 bit. Okay, now after changing this, right, now if I enter like it gets like B is also 32 bit operator. Okay, so then yeah, here it is like 2-bit input operation. I mean for operation, like it's suggesting 2-bit because we said I mean, in the first line, we said addition, subtraction, and bitwise AND operation, right? So it gets from that, like only 3 operations were there. So 2 bits are enough for the operation. Okay, so it is suggesting to use the 2-bit. If I want to use more operations, I can change it to the, appropriate bits. Okay, but as of now, just I'm accepting this thing. Okay, and maybe I can add one more thing, like some no op. Okay, no operation. Like nothing will. You may see. We have to define what no op means, but we can define later. Maybe uh, output output is always 0 for no op, something like that. Okay. Okay, and now it is suggesting for outputs. Okay, and yeah, this thing I'm not going to take, like result is 0 or not. Okay. Maybe I'll just maybe I will add myself instead of taking it like carry. One bit output flag. Okay, and okay, again it is suggesting 0, but I don't want to take it overflow. Okay, overflow bit. Okay, yeah, so I am taking like carry and overflow because carry anyway, you understand, right? If you add two things, it may result in a bigger number. Okay, similarly overflow, if you if we are using signed integers, it may result into the overflow. Like when two negative numbers, if you add, it may result into positive number, or two positive numbers if you add, it may result in other things, right? So something like that. Okay. Yeah. Okay. I think yeah. Along with that, right? We want some control signals. Okay, when to start the operation and all those things. So I want to keep it simple, like start. Okay. One bit. Okay, one bit signal to start, and done signal as a output. Okay, once the operation is done. So I'm taking this as is. But another thing, another signal I want, busy signal. Okay, which indicates ALU is under. It is doing operation, so that I cannot give a next operation, next start. Okay. So maybe we can define what kind of protocol we want. Like if busy, I cannot give a start. Okay, or it will ignore the start even if I set it. Like if the busy signal was low, then our start will actually result in the actual operation. Okay. Similarly, like output side also, we can define some protocol, like done was high, I have to remove my start from there. Something like that. We can come up with that. Okay. Now, so with the above context, maybe just I start. Maybe I will start with my code. Okay. So actually, I'm waiting for Copilot to view the rest of the code. Just by the way, like we can ask this Copilot to generate the entire code. But say if I ask, say generate the code, it will suggest module to end module, everything. Okay, but most of the time, what will happen is we end up debugging the generated code. Okay, which we don't want to, because if someone writes, right, debugging it and understanding that will be harder, right? Okay. Yeah. So now it is Copilot is taking that, and maybe just accepting it. Okay. Because all these things we already defined above, right? So that's why, like, yeah. Where I am, like I am telling, right? So you can ask the entire Copilot to write the entire code. but which is not a recommended thing. Okay, because you have to spend a lot of time to debug it. Okay, so instead of that, we can ask step by step. Okay, give some suggestions. Take the output. If that is not matching with your expectation, you can ask for a next suggestion, or you can just edit the code, and from there it will catch what is your intention. Okay, so such things, like you have to start small and ask small, and step by step you have to go. So that way, like if you write this entire module on your own, right, if it takes some, say, 1 hour. Okay, but using this thing, like maybe within 10 minutes, with your code suggestions and all those things, if you go slow, step by step, maybe 15 minutes you can finish. Okay, same module, like okay, so maybe yeah, so now it is giving the entire, like earlier it is giving one by one, right? Now it is giving the entire things in single shot. So maybe I will accept as it is, because we want to add the results, I mean, internal signals. Okay, so register to, like I do most of the time I will register the inputs once they were started. Okay, maybe okay. Okay. This is not from the Copilot. It is with. Let me see. Suggest that. Yeah. Now it came. Earlier, what I showed is just VS Code code completion. Okay. You don't know the syntax. I mean, you don't know the context. You just give the thing. Okay. So I hope this looks somewhat fine. Okay, but yeah, first I will accept this thing. Okay, or maybe like I want to show some more things. I can pick one of the thing. Okay, it showed three, but I am picking the second one. Okay, second one, and accepting, like just but here my intention is like not to register every single cycle, but I want to say there is a start signal. Okay, so the suggestion to, like maybe let's go with this thing, and busy, it's not busy basically. Okay, so if there is no busy signal, and there is a start at the input, then I want to register the things. Okay, so we are done with this thing, but at the same time I like busy was not there. Okay, let us keep this simple, like other controls maybe we can add later. Okay, here maybe we can have a actual logic. Okay, this is showing as a combo logic. Okay, yeah. So okay, before going that, maybe we can have a other approach, like ALU operation as enumeration, so that like we enumerate in. Okay, so now maybe it suggests this. Okay, yeah, now it is using the enum keyword to come up with the actual. Okay, yeah, now I can ask the logic. Yeah, I want to make it simple as of now, like because I want to focus more on Cocotb side. Okay, yeah, this is good. This looks good. Maybe for time being, I can ignore what to say. Okay, so this is some default also it is expecting like I mean, my linter default. Okay, so it is expecting some default also. So we are having this thing. So it does on what do you say on registered inputs. Okay, so op, reg, and A and B registered one. Okay. Yeah. So and one more thing like it is giving some right, but we can directly assign to the result. Okay. Yeah, as a just for time being and just doing myself manually. Otherwise, like I think we can do this. Sorry. Okay. Maybe registered output. I mean result. Instead of giving into the register, I can give directly. Okay. Then we can register this. Or okay, either way is fine. Maybe after running a test, we can update this if required. Okay. So yeah, maybe carry overflow for the first test case. Maybe I can ignore. Okay. So what we want is some control logic, for done and easy and done. Okay. So okay. So maybe we accept this thing first and see what it does. Okay. So what else? Okay. If I start and it is not busy, maybe I will turn this busy. Okay. For outputs, I don't want to take the registers. Just I will take this thing. Okay. If it is not busy and the start signal is there, I want to set busy again so that like next start won't come. Okay. So then if it is a busy, okay. Okay. So if it is busy, then in the next cycle, by that time, like our result will be valid, right? So because it in the next cycle it will be valid. So I want to assert the done signal. Okay. I want to release the busy and I want to assert the done. Okay. But at the same time, like how many cycles we have to hold done, like that we can define. Okay. If start is 0, that means from the we accepted the start, right? Now we have to just release it 0. I mean then yeah, we can remove the done signal so that like we started and it was busy during the operation and it asset done, and we are acknowledging that done by deasserting the start. Okay. I think so far I got that correct. Okay. So maybe yeah. So actually, carry and other things we can add them here itself. Okay. Um, yeah. So for now, for time being, like just I will ignore the carry and overflow for now. Okay. So I think so far we are good. Maybe to see any syntax errors and other things, maybe I just run it. Okay, so with the default test case, so that I will come to know. Okay, this time I will add verbose to this thing, so that like we come to know what is going behind. So it's still compiling. That's why it took that much time, I think. Yeah, earlier I used Icarus tool to run this thing, but sometimes some SystemVerilog constructs are not supported by Icarus. So I moved to the Verilator, which is also open source. But both has their own limitations. You cannot run UVM test benches with these tools. Okay, you have to go for proprietary tools like VCS or Questa. Okay, so but usually like it's a good idea to use the open source tool for this kind of things. Okay, so yeah, so far I think syntax and other things are correct. Okay, now we can focus on test writing. Okay, so I'm keeping this basic test as it is without instead of removing, so that like for next runs at least we should able to see one test case pass when everything goes correct. Okay, maybe other test cases may fail because of a logic error or test bench error, but at least we'll see at least one test case passing every time. Okay, now I want to like maybe I can add yeah, for time being we can just ignore this thing. Okay, that is anyway static one. Okay, so all right, test case one. Okay, here what I want to do is a simple and add. Okay, I think that okay, so it is trying to suggest like use a Cocotb test bench, and yeah, so I think we already gave one example above, right? So it is trying to mimic that and give the similar structure. Okay, but it trained on some old data, so it may not know what is the new thing. Okay, so what I see here is some different, like we cannot directly assign what to say. Okay, before that maybe I will just add one more line. Okay, like we want to use enumerated for ALU operations. Okay, I think we want. Okay, so yeah, it is trying to suggest something, but we can just say what we want. Like we want to add stuff and just maybe here. Yeah, sometimes it may not give something weird, but we can always just end operation. No, no. Okay. Now with this thing, maybe here if I start writing. Okay, so we created clocks. Just give me a second, like I have an issue with my mouse. Yeah. Okay, we created a clock and reset and waiting for the reset. DUT to come out of reset. So far here, good. Then here I can just DUT. And so our I'm just waiting for the Copilot to pick up, but since yeah, maybe we can start from scratch. Yeah. Okay. Now you see it took the ALU, but what I want here is actually okay. So in latest Cocotb, we cannot directly drive the things. We have to give like this. Okay. You don't need that that equal, I mean, less than equal symbol. Like you can directly assign directly. Okay. So maybe we just yeah. Here also just value. So, okay. So one more thing I have to tell, like since this is very basic test, I can directly go and run it. But okay. It says this was not available. Okay, I think it's int enum. Yeah, now we corrected it. Okay, but, let us see like what's went wrong. Okay, so yeah, so I think we overlooked it. So there is no y, right? I think initially, if we start saying like these are my input ports, it may do correctly, but let me correct it. Result, right? So our signal name is result. Okay, now we can. But again, okay, yeah. So if you see, right, we had already defined some protocol. Okay, so without doing anything, like we directly seeking the result. Okay, so what we need to do is like before okay, let us okay wait for what's say busy signal to go low. Okay, yes, during busy signal is one, like it is waiting for some cycles. Okay, let me go through the RTL ones, like initially. Okay, initially our busy signal and done signal are zero, right? So that means like it's okay. um, okay, now okay, start the operation. Okay, so we are giving DUT start as a one. Okay, now what we can do is like wait for done. Okay, to go high. Okay, similar to thing. While done is zero, it just waits. Okay, then we have to just release start. Okay, so just based on the protocol we defined there, like just I'm giving things. Like initially we gave start value as 1. If it is not busy, then we waited for the done signal. Okay. We waited for the done signal. Let us see how it works. Okay. I don't think we need to wait for one more cycle. I can, because it was done, I can immediately. Okay. I think we can put there. Okay. Again, maybe. Yeah. Okay. Sure. It seems it is something else, but okay. So I got the thing. We have to name our test cases something else. Okay. So here what happened when I run the PyTest, right? So PyTest is the Python test framework. So it simply parse to the all the files, I mean Python files in the current folder, and whatever function name with test, it start with the test underscore something. It is trying to run the test as it is. Okay, so that's why like we saw. Okay, Cocotb test bench was running, and it is passing. Okay, so this one like a test underscore something, this is the first one to start, and this test 93 line will pick the actual test cases like which are decorated with cocotb.test. But instead of that, after this what happened, PyTest actually tried to run this as is, which is not correct. Okay, it cannot run like that. So we have to take care, like to avoid PyTest to pick this directly. I can just I can name anywhere like a simple this test I am moving back. Okay, now we can see like it will clearly say pass. Okay, only Cocotb test benches are passing. Okay, yeah, I think so far I cleared all the things. Okay, maybe at this point I will just take a break for a few minutes, and let us go for some questions if you have. Okay, yeah, maybe you can ask in the chat. I mean, so far what we did, like we simply added some simple ALU with some operations, and we created one protocol like start, busy, and done signal. And same thing we have tested in the Cocotb. Okay, so like if you have any questions so far, like maybe I can take them now. Yeah, please use the chat if you have any questions. Okay, maybe I continue with the other things. Okay, so let us. Okay, here we have few. I mean, we did a very simple test. Okay, but what we want is, say, if I generate the value randomly. Okay, say my test case 2 is add with random 32 bit. Say as of now, like just take the regular numbers. Okay, 32-bit numbers. Okay. Okay. Okay, maybe just 10 rand 32-bit numbers. Okay, that means like I am going to run this in a loop of 10 with A and B generated randomly. Okay. Okay. Now it took like based on okay, so it's exactly mimicking my style. Like I already gave, right. Initially, just give dut.a is equal to some value is assigned. Now I updated with the dot value, right. So now it is coming as correct. And this protocol is also taken care. Okay. Now I can just like since I asked, they are like 32-bit numbers only. So it is picking from 0 to that maximum number. Okay. So let us see how this works. Okay, just I think. Okay, so it seems something overflow. Okay, say whenever it generates the different numbers, right? So actually, what is happening here? It has some overflow. I mean, not overflow exactly. Like it has a carry. Okay, so these two big numbers were added, and it was expecting some. I think it has a carry, which like if you took 33 bits, maybe result will be matching. But since we are truncating a 32-bit result, so maybe it has some flow. So in this case, what we have to do is like we have to update, like we have to tell, like just compare. Okay, I'm removing it. Okay, compare the 32-bit result. Okay, so instead of looking whole thing, just it has to compare only 32 bits of the result. Okay, so that like it will match with the our implementation. Okay, still it is failing. Let us see. Hmm. Okay, so I think maybe like can just once that is done, maybe we can compare first and release the start. It's still failing. Maybe I will limit the numbers to some lower things. It's failing. Okay, seems some bug in the code itself. Like let us see. Hmm. We gave the operation as a this thing only. Okay, let us limit to 1 or 2 and see if it works. Limit the screen. It seems like some issue with the that handshake only, but let us see that. Okay, let us fix one of the value to 0 and see. Yeah, so it seems like it is issue with the protocol. Maybe like I will make 1 plus 1. Okay, just I'm doing a direct test case so that like we can understand what is wrong. Okay, so it seems A and B values are not getting updated. Yeah, I think we have to see like these A, B are coming as different than what. Okay, sorry. Yeah, that anyway will fail, right? We have to just update here, okay, rather than there. Okay, now we can just compare it correctly. Just I want to see like if I run more times, is there any issue? That's what I want to confirm. Uh, just let me keep this. Maybe some 10 members. Okay, I'm just varying A so that like if there any issue with the protocol, now we will know. Okay. See, I think we got 8 and but actually we are expecting 9. Okay, that means somewhere that restring is not happening. Okay, previous value is actually coming. Okay, maybe let us wait for one more cycle before comparing the result, because as soon as done is there, like we are taking the result as it is, right? So maybe that is causing the issue. One. Okay, let us fix this thing. If there is a start, we are just setting start. Then let us do this thing. Maybe in the RTL itself we had an issue. Uh, when there is a start and the busy was not there because we are waiting for the busy, that means if you set start, Yeah, just give me a minute. Like I'm just wondering what is going wrong. If there is a start and busy was down, okay, immediately next cycle actually busy will go down. Okay, then we have to wait for uh, I want to see whether it is a bug in the design or this thing. So we'll remove done only if there is a if we assign start to 0. Okay, till that point, I think. Yeah, please pardon me. Like I think I did this exercise twice, but let I. Okay, so it seems some bug in the thing. Okay, so where let me cross check. Uh, okay, let me add one more thing here. Okay, I think it is when done is not there and busy is not there, then only we have to take this thing. Let us see if that helps. Okay. Yeah, by the way, we are just going by like a test driven method. Okay. It is taking some time to compile. Yeah, depending on your simulator, it may take a minute to like few minutes. And yeah, still it is failing. Let us see. Actually, value is coming instead of 2, value is coming as 3. I'm not sure what is happening. We have A and B here. So it is taking actually previous, I mean, previous value. The result is coming as like next one. I'm not sure how it is in, like 4 plus 1, it should be 5. Instead of that, it is coming as 7. Let us cross check, like we are doing add operation only. It is 0. So as long as we hold A and B registers and off registers, which we remove, I mean, those things should hold actually. But how come it is going beyond that number? Like I'm wondering. Okay, so in first cycle we just registered the operations and we said it is busy. Okay, like same. Let me rerun once again. I'm thinking like something happened at the protocol level only, not in the operation. Meanwhile, I can cross check what is happening. Yeah, we are adding some simple numbers only, so that's why I'm wondering what is happening. Actually, I expect overflow and other things will be will create complicated, but unexpectedly this protocol wise we're seeing the issue. Something stuck at old value. Okay, let us wait for one more cycle here after giving the start value, or maybe 2 cycles before giving the next operation. Yeah, I think that is the issue. So here, what we are doing, we are giving the start value as 0, and immediately we are resetting and something going to the next loop. That's why we are seeing next value. So before giving the next operation, just I'm waiting for a few cycles so that like it can. Okay, maybe now we can run with the actual values. So it will be tricky, like I mean, because I made up the protocol on the fly, right? But if you have a proper specification how to do and other things, maybe it will be easy. Like if you can explain your specification about protocol plain English. I mean, usually you start with the specification, right? We'll have a clear understanding at what cycle what is happening. Okay, so yeah, I will update to the original 32-bit random numbers. Okay. So it seems like that. Yeah, now everything looks good. Okay. So what we are doing is like we created 32-bit random numbers, and we are using this protocol to wait for done signal, and we are just comparing the value against our expected value, and we are taking only 32 bits. Similarly, we can you can do for subtractions and all the other things. Maybe I will just quickly ask to add STS3 and operation. I think like we are overshooting the time, so I'm just adding one more test case for and. or maybe okay. And so and so 10 times I want to add so that like it just randomly pick okay. I asked for add and okay. So I think I want to say and okay, simple ALU and in or 10 test cases. So based the result will be based on the and it will have right. Yeah. Now we can run it again. Okay. Okay. So I think we didn't add our or operation. Okay. Maybe just we define that instead of no. We can quickly update it. So we didn't define the or operation originally. So maybe that's it is. I think they should. Enum also, I think we didn't add. Okay. Yeah. So if it is and operation, it is doing. Otherwise, I think I can just have it. Okay. So if it is and do and otherwise it will do or. Yeah. So I think we within 1 hour I want to cover all the test bench, whole test bench, but unfortunately I think I overlooked something and it ended up like taking more time to fix those things. But it's you see right what we did is like very basic thing. Okay, maybe if you do more, your Copilot can understand your intentions very well. Okay, so that like in future you may have less iterations if you are writing any complex code. Okay, so I think I demonstrated like I showed you right initially try to put something else like then once I gave a sample test case, so it quickly picked my style and created the next test cases for it. Okay, so yeah, maybe because of we overshoot the time, like I'll stop here. Maybe I can take the questions. Yeah, please ask your questions in the chat or if you want, if you put the message, like maybe I can unmute you and you can ask for the audio. Okay, so I think Yashwant is asking. Okay, so first question first question from the Yashwant is like, what are your suggestions for someone to start in VLSI domain at the company, either in verification or RTL design? Okay, so yeah, I mean both are valuable. Like without design, you cannot do anything. Like without verification sign off, that also you cannot have anything. So both are good places to start. Okay, but as an industry, right, most of the time verification is the like 70% of project time depends on the verification. Okay, so it will take 70% or 80% just for verification. Okay, so for that, like for every single RTL designer, there is a need of 2 verification engineers. Okay, so that's why you see more verification engineers. I mean, demand. But unfortunately, people even in software also, right? There is a difference between saying you are a tester and you are a developer. Okay, but for VLSI, that's not the case. The verification has a more importance and thing. Okay, it's up to you which one to take. But what I can say is, like as an RTL designer also, you have to do some verification on your own for unit test and other things. I mean, before you hand over to your design to a verification engineer, you have to ensure it is in proper condition, like 0 bugs, maybe corner cases at system level, but as a unit, if you are delivering, it should have you want to raise the initial RTL quality. So everyone should learn verification, I can say. Okay, irrespective of your role. Okay, but RTL designer, yeah, you see the value, like you can say I designed this chip and all those things. It's like matter of how you project yourself, but both are valuable. Okay, but as I told, right, everyone should learn verification at some level. Okay, whether at a unit test level or complete SOC level or complete system level using UVM, that is different. Okay, but up to some point, you should have a verification role also, even though you hire for RTL design. Okay. Then second question, how does one keep oneself updated with all the ongoing improvements in the tools and various design concepts? This is hard to tell because unlike software, most of the stuff is within the company. Okay, and all new things will be kept within the company boundary only. So, but yeah, you can see the open source tools, and you attend all the webinars, like say Verification Academy, like Verification Academy. Some those things are like Siemens. They provide the Verification Academy training and all. So most of the stuff, it will be available freely if you register. Okay, yeah, but you have to go through by internship or maybe by working. Okay, as a student, if you are asking, it's very hard, but still we can get into a good course. Okay, and other things. Okay, but you have to keep watch on all open source verification and design tools are really getting uh, good good improvements. So whatever you learn there will directly applicable to the job. Okay, there is no, I mean, earlier very few, but now things are coming, right. Even this IWay, I mean, very later, all those things recently they have added UVM, but still it is in state, but that will help you to learn any new concepts. Okay. uh, yeah, so third question is like what challenges did you face when you entered into design? How did you overcome these things? Okay, for me, I have a little background actually before entering to the industry. Like I'm doing my MS and then PhD, so I have exposure even before entering into the industry. But even before, like since 2007, I have my own laptop and Ubuntu installed. So I did myself like basic open source tools and other things. So internet is your best friend. Like you have to explore lot, and you will get all the information. Okay, I mean, but I have a hands-on experience, like using open source tools that will give your exposure. Like because same things we'll use in the industry, but with a different set of tools and with increased quality. That's the only difference. Otherwise, everything you learn on internet is same as what we do day to day. Okay, I mean, you have to expose yourself. Okay. Yeah, I mean, self-learning is a must thing. Like now today compared to 10 years or 20 years back, now you have more information available on online. Okay, even this Copilot for some students, I think it was free only. Okay, you can use this to learn new things. Okay, I mean, you don't need to depend on it that much, but it can quickly tell you what kind of things that are already available in the web, so that like you can have a chat with chat GPT or this Copilot. That's how you have to expose. Okay. Yeah, so last question is what are some crucial factors that one must remember throughout one's career in VLSI? Okay, and sustain job role. Okay, so yeah, and you will learn different. I mean, there is no single path. Okay, so you enter as some verification engineer, then you convert to a design engineer, or some other role, or validation engineer, or some yeah, something like post silicon. So throughout your career, depending on your company, how much they do, you have to just explore the opportunities. I mean, you should not stick to one role. That's what I want to say. Okay, to get the exposure, even without any project also, you should start exploring. Say, in my case, I started with HLS. Okay, when I entered into the company. Okay, like reward of HLS and other things, but I worked on it, and then I mean, just for fun I learned it. Then later stages, when there is a role, I just went through it, and I did that project where the HLS is the main one. So even before things come to you, you have to get the exposure by just using your spare time to explore many things. Actually, that's how I learned the Cocotb. Okay, when I started 5 years back, no one is interested in Cocotb or Python verification. But I still went ahead and just clone their Git repo and install it, and slowly learning all those things I did. But now, if you see, right, since 2022, this Cocotb was picking up by the industry. Okay, I mean, in one way or other way, they are interested, and maybe in next 5 years, this may become mainstream also. Okay, of course, it will not replace the UVM test benches, but from the other things like unit testing and modeling, system level testing, those things maybe you can expect from Cocotb. So that's what I'm saying. When I started, no one is doing this, but I did myself out of my interest. Then now it became a mainstream. So you have to catch those things early, so that you don't need to learn. See, when everyone is doing, if you are doing, then maybe like if things comes to you late, by that time, if you are not aware of that, like maybe you cannot sustain, right? You may lose the opportunity. Sustain means like you may lose the opportunity, it may go to someone else. Okay, that's how you have to throughout your career, like, just explore and be ahead of your current things, and learn new things. Okay, on your own or through some forums, whatever way, I mean, whatever way fits to you. Okay. Yeah. That's it. Like, I mean, in the demo, like whatever we did so far, maybe if you have any questions, just mail me that we have that thing, right? Uh, I'll give my email ID. Like, okay, just I'm pinging my email ID in the groups. Yeah, it's a Srinivas at verificationexpert.com. Actually, like, I don't know whether this is appropriate forum to tell next things. Yeah, I think in the chat there is another question. Uh, Okay. Another question asked by, I think, Yashwant only. Yeah, Yashwant, maybe that we can, I think it's specific to you. I think we can connect offline, I mean, later. Yeah, so just I want to announce, like, I don't know how many of your students are early in the career. Like, I'm starting a course, I mean, online course, like through Zoom meetings only, on verification with Cocotb. So I see that like major, it is going to pick up. Okay, so by that time, like we have to prepare few verification engines to train on it. Okay, so I think this is a best time to catch on Python based test bench. Okay, maybe if you are interested, mail me on this mail. Okay, I can give more information on it. Mm, yeah, so maybe it's a paid one, so that's why. I mean, I want to put some efforts, right? That's why I'm putting it as a paid course. So if anyone are interested, maybe just ping me, or just go through the go through the things. So I want to just put. It's like we'll teach it, but with the I mean, if you want, we can enable the Coco Pilot. I mean, that Chat GPT Copilot for you for just during the course period. Okay, maybe I mean with a discounted price for the Copilot. Okay, I mean you may need to pay less for Copilot what you are getting outside. Okay. Yeah, feel free to connect me over email if you have any questions. Yeah, I think we already like a half an hour late. I mean, yeah, yeah. If you don't have a more questions, maybe we'll stop here. Okay, yeah, just connect with me offline if you have any questions or any concerns. Yeah. Okay, then bye everyone. Maybe I'm ending the meeting here. Okay. Yeah. Bye.